Hey, we're back. We're going to do percent change and percent error real quick. It's going to be a shorter video because I didn't want to make that last one super long. These are formulas that will not be on your little handy dandy milestone formula cheat sheet. This is going to be something that you have to just remember. All right, so we're talking about percent change, percent error. When it says percent change, that could mean an increase or a decrease. It doesn't mean one or the other. It means it's changing one way or the other. Percent change. All right, I'm going to write down both of your formulas real quick. And then I want you to just know that these you have to know for your testing purposes. So percent change, to figure out the percentage that something changed, you've got to find out the amount of change in something, amount of change, divided by the original or starting amount. And then we multiply those by 100. This is the formula. So percent change, to find out the percentage that something changed, you've got to find out the amount of change. And to do that, if you remember, to find the amount of change, you have to subtract to find the difference in something. So if I used to be 300 pounds and now I'm 150 pounds, it changed. The amount of change was 150 pounds, right? We found that out because we subtracted the old from the new. And so that's what I'm talking about when I'm talking about the amount of change. You've got to subtract to find the amount of change, right? So we would subtract to find that amount of change. The original amount was the first amount, whatever I started with. So in that scenario, if I used to be 300 pounds and now I'm 150, well, the original amount was 300 pounds, right? So that would be what goes on bottom. Now, it could go vice versa. I mean, I could have be 150 pounds right now, and then in 2 years, if I keep eating birthday cakes, I could be 300 pounds then. The original amount in that scenario would be 150, and then it would be a percent increase because that number went up, right? But it's still finding the percent change. At the end, you're just like, is that a percent increase or decrease? Let's do a quick percent change example problem. So we will use this formula, and I'll read a quick word problem to you. Jack sells t-shirts for his school during the football games. At the first game, Jack sold 120 t-shirts. At the next game, he sold 68 t-shirts. To the nearest percent, what is the percent change in the number of t-shirts Jack sold? Well, you've got two different amounts. You've got the first game, which was 120 t-shirts, and the second game, which was 68 t-shirts. We automatically know that's a percent decrease because he sold less the second time. So in this percent change, we know it's going to be a percent decrease because that number went down. The first thing that we've got to find is the amount of change. We've got to subtract to find the difference. So we started with 120, and we're going to take away 68 because that's the difference in the amount of change. 120 minus 68. Now on the bottom, remember, goes the original or starting amount, which this time was 120. And then of course we're going to multiply that by 100 because it's going to give you a decimal, and you've got to change that to a percentage. That's changing percentages to a decimal. All right, so let's do it in the calculator. We've got 120 minus 68, which is 52. Oh, these blue ones don't do well. 52 over 120 now. You, in your calculator, will write 52 divided by 120. 52 divided by 120. When you do 52 divided by 120, that gives you 0.43. And the 3 goes on and on. It's a repeating decimal. But we haven't multiplied by 100 yet. The reason we multiply by 100, because it's not a 0.43%. It is times 100 is a 43%, and we know that that is a decrease, a 43% decrease. We found the percent change through this formula. We knew it went down, so we knew it was going to be a decrease. The amount of change goes on top, the original amount goes on bottom, and then you times by 100. That's a percent change. right? One more almost exactly like it that we have learned is called a percent error. A percent error is when something is supposed to be one way and it's off by a little bit. The easiest scenario that I found was the bag of flour in the book. When you go to the store and the bag of flour says, this is a 5-pound bag of flour. Well, if you weigh it and it's not 5 pounds, it's 4.5 pounds, that's an error. It should weigh 5 pounds, but they're jipping you. You're not actually getting 5 pounds. That would be a 0.5% or a 0.5 error in what it should be, right? So let's do the formula for percent error. Percent error is almost the exact same, but on the top, when you subtract, you are writing or finding the amount of error, which in that scenario would have been 5 minus 4.5. On the bottom, which for percent change you use the original amount, percent error, you use the correct amount. The bag of flour scenario, the correct amount should have been 5 pounds, right? That would have been the correct amount. And then again, at the end, we're going to multiply by 100 because that's going to be changed into a percent. Another word that they'll use on your word problems instead of correct is the word actually. It was actually this or actually that. If you see actually, that means that's the right amount and that's the number that goes on bottom. Okay, here's your percent error formula. The amount of error goes on top. How do you find the amount of error? How did I find the amount of error between the 5-pound bag that it should have been and the 4.5 that it was? I subtracted again, just like percent change. So you've got to subtract to find that top number. Subtract to find the amount of error. Divide that by the correct amount or the actually, and then times that by 100. All right, let me look on today's test and see if we have an amount of error here anywhere. To the nearest percent. Yes, we do. So a contractor's doing a job at a house. He estimates that they need 18 sheets of drywall. They actually use 14 sheets of drywall. So let's do that. All right, the contractor says they need 18 sheets of drywall. That's his estimate. The word estimate a lot of times will go up here and you subtract that from the correct amount. That's a lot of times the amount of error, what they estimate minus or take away the correct amount is a lot of times how you'll find this. So the contractor thinks or estimates 18 sheets of drywall, but they actually used 14. So that's going to be the amount of error. The correct amount was, again, the word actually. That was the 14 because that's correct. That's what they actually used. And then we will times that by 100. This will give us the percent error. This is the contractor's best guess estimate. This is what they actually used. Take that away. We've got 4 divided by 14. In your calculator, 4 divided by 14 gives us 0.28. Then we will times that by 100 up here, times it by 100, and the percent error here was 28%. 28% was the percent error. Okay, same exact type of formula. You've just got to always subtract to find the top up here, the estimate or what they think minus the correct amount. The bottom will be the correct amount, or use always look for the word actually times 100. All right. Okay. Percent change and percent error. That's about it. That's all I got for that. Remember to know how to multiply by 100 to change those percents or those decimals to a percent to get your percent error. And remember that you always subtract to find that top number. Okay. I hope you guys do well. If you have any questions, let me know.